Last week we learnt about the discovery of radioactivity by Marie and Pierre Curie. Today we're going to introduce a little bit of the theory about the different types of radioactive decay. We see radioactive decay in lots of different areas, in films, in TV programs, and in everyday life, such as nuclear power stations. If we take The Simpsons as an example, we can see here some ideas that people might have about radioactive materials. That they cause mutations in fish to have 3 eyes if it gets into the rivers. That it's a controversial topic, with some people not being happy about the use of nuclear power stations. That radioactive materials will glow, or that radioactive materials can cause accidents which could be dangerous. We're going to learn a little bit more about these items in more detail during today's lesson. During the lesson today, what I'd like us to do is introduce the 3 types of radioactivity and their properties. Bronze need to state the 3 types and their names. Silver need to describe what these 3 types of radioactivity are made from. And then gold need to explain their properties and why they might be dangerous in certain situations. So what makes a radioactive material? As we've learnt before, all materials are made of atoms, and most atoms are stable. However, to get a radioactive material, we have atoms that have an unbalanced and unstable nucleus. They want to become more balanced or more stable, so to do this they give away their excess energy in the form of this radiation. This radiation can be emitted in one of 3 ways. When this radiation is emitted, we call it ionizing radiation. We know from chemistry, earlier on in the year, that an ion is a charged particle, caused by losing or gaining an electron from its outer shell. Now with ionizing radiation here, we are always creating a positive ion, because radiation being absorbed by an atom will cause it to lose an electron. This ionizing radiation is dangerous to human cells and can cause them to mutate, which sometimes can lead to cancers. We measure radioactivity in a unit called becquerels, or doses, and we can detect it and measure it using different pieces of equipment, such as a Geiger-Müller tube or Geiger counter, which is the yellow object in the bottom of this screen. The first type of radioactive material is alpha. As with all types of radioactive material, we start with an unstable nucleus, which once alpha is emitted, creates a new nucleus and the alpha particle. The alpha particle is actually made of 4 types of particle that we know about. It's made of 2 protons, which are positive, and 2 neutrons, which are neutrally charged, from the nucleus of the atom. This alpha particle is the same as the nucleus of a helium atom, but it's travelling at extremely high speeds due to the high amounts of energy that it's got. It has a mass of 4 because it has 4 particles from the nucleus, and it has a charge of +2, as we know protons are positively charged. The second type of radioactive decay is beta. Again, we start with an unstable nucleus, which tries to become more stable by emitting a beta particle, creating a new nucleus as it is emitted. A beta particle we've also seen before. It's a high-speed electron. Now we know electrons aren't found in the nucleus, so what happens in beta decay is that this high amount of instability causes a neutron to be changed into a proton and an electron. So the beta is a high-moving electron, therefore it is negatively charged, but has virtually no mass at all. The third and final type of radioactive decay is gamma decay. Again, it comes from an unstable nucleus, but unlike alpha and beta, gamma cannot exist by itself. It is the excess energy emitted either with an alpha particle or a beta particle. The actual structure of the nucleus isn't changed by the emission of gamma, as gamma is a very high energy, high frequency, short wavelength wave. So it's just energy. It has no charge, it has no mass, but it's excess energy to try and make that nucleus become more stable. When we take each type of radioactive material, we can see that they are different sizes and have different properties. That allows us to look at how we protect ourselves from these types of radioactivity. We can see at the top of this diagram, alpha particles are the biggest, largest and heaviest of the three types of radioactive decay, as it's made of 4 different particles. Therefore, it's relatively easily stopped. It will travel through very, very thin sheets of plastic, but is easily stopped by skin cells or a few sheets of paper. Therefore, if we were to get an alpha source, we could protect ourselves by putting paper between it. It has a low range in air and is easily stopped. Beta particles, as they are smaller, high-energy electrons, will travel through those few sheets of paper and are stopped by aluminium. A few centimetres of aluminium will absorb the beta particles and not allow it to transmit through. Gamma, being energy, is much more difficult to stop. It will travel through the 3 materials we've mentioned so far, and if you look at the right-hand side of this diagram, you can see that it travels through thick lead. It's only reduced, not entirely stopped. So gamma, we need quite a significant amount of lead to be able to protect ourselves from it. One other thing you'll notice is that we use Greek letters to represent our 3 types of radioactive decay. The Greek letter alpha, the Greek letter beta, and the Greek letter gamma. When we look at the size of these particles, we can also think about how ionizing they will be, how much danger they will cause to human cells, and how much damage they might cause and mutate possibly the cells on impact. As alpha is the biggest, it will cause the most damage. It is the most likely to cause ionization, whereas gamma, being an energy form, is less likely. It's still ionizing and still potentially dangerous, but will cause less damage than alpha or beta. You could pause this now and fill in this table from the notes that you've made. What's the symbol, using the Greek letters? What's it made of in terms of particles or not? What charge, mass does it have? What materials will it be stopped by? How far might it travel in air? And which is the most ionizing to least ionizing? You might want to use this summary to help you. If we look at what you fill the table in with now, we can see the top row, we have our 3 Greek letters, alpha, beta and gamma. Beta being a capital B with a little tail, and gamma being almost an upside down Y shape. Alpha is made of 2 protons and 2 neutrons, beta is 1 electron, and gamma is an energy form. Alpha particles have a charge of +2, as there are 2 protons in there and we know they're positively charged. Beta has a charge of -1 because we know it's an electron and they are negatively charged. Gamma, being an energy form, doesn't have a charge. Alpha has a mass of 4, as it has 4 nuclear particles in it, 2 protons and 2 neutrons. We know electrons have virtually no mass, so we say the mass of a beta particle is 0. And again, gamma, being an energy form, doesn't have any mass at all. The 3 materials here are 3 materials that you need to know. You need to be able to recall the fact that alpha can be stopped by paper, beta can be stopped by aluminium, and gamma can be reduced by lead. The range in air, we need to know alpha won't travel very far in air and has a short range, only a few centimetres. Beta has a medium range and gamma has quite a long range and will travel quite far through the air. The ionizing ability is due to the size of the particle and how much damage it might cause to human cells. Alpha has a high ionizing ability, beta is medium, and gamma is the least ionizing out of the 3. Now there is a quiz attached to epraise, a multiple choice quiz of 15 questions, so you can show me what you've learned from listening to this narration. I hope this helped as a different way of learning this week. Let me know your thoughts via the epraise messenger. Well done, thank you.